Alright, so I'm going to talk about doing a lithium ion conversion on this drill that I bought maybe 18, 20 years ago. Um, it is a great drill, except for the batteries that were available at the time were much worse than what we have today. Basically, these are NiCad batteries. Um, and even brand new, they're not the best, but now this is an almost fully charged battery. You can see it's not great. But lithium ion will completely fix that. So what I did is I took one of these packs here and I took it apart. Um, so here's the cells here, which I'm not going to need anymore, so I'll recycle those. And here's the pack itself. There's the top, the bottom, and then I've already modded this, but this is the little plug part that plugs into it. So originally this was welded onto there, but I just peeled it off with a pair of needle nose pliers, and I welded on contacts. Pretty simple. And there's also this third pin here. So far all I've used is a multimeter, so I know that there was 16 volts here, here, 16 volts here, here, but these two are not shorted together. There's some sort of device there. I don't know if that's like a thermal resistor or a diode or what. But it was also tied to the negative terminal of the battery, so I just tied it to the negative terminal here. And I've already tested this and it works just fine. So this was like the prototype. What I'm going to do now is 3D print some sort of bottom for this so that it will nicely take a battery. And I'll show you what battery I'm going to use. A couple of different choices there. And for this, I probably won't use this. I mean, there's different ways you could do it, of course. But these little clippy things can pull out. So I'll probably use those. Because there's like some metal in there. And they would be pretty convenient for keeping that clip mechanism. Since this is a battery conversion project, I thought it would make sense to talk a little bit about batteries. You can talk about batteries for a very long time and not cover everything there is to talk about. But that's not the goal here. The goal here is just to give you a brief taste of things you might want to know. And then I'll leave the rest up to you. So this is the pack that originally comes with the battery. It's a NiCad pack, which has 12 cells, and that will give you a voltage of between 14.4 and 15.6. All batteries, and especially NiCads, drop voltage as you apply load to them. So as the drill actually applies load to this, the voltage will drop quite a bit below the 12.6, especially when they're low, and that's where you'll hear the drill start to sound like it's running low. These, on the other hand, are lithium-ion batteries, LIPO in this case. These run between 3 and 4.2 per cell, although usually you want to keep the voltage above 3.7 per cell. And in order to get the same number, approximate voltage over here, you're going to want either 3 or 4 cells if you just do the math. For example, a 3 cell, which is this guy, will give you 12.6 volts fully charged, and a 4 cell will give you 16.8 fully charged. You don't have to fully charge the batteries to use them with the drill. So one option is you could partially charge this. The other option is you can just hope that 16.8 works out. It is just a motor after all, and even though it might not be so easy on it, it might be okay, especially if you're just doing light loads. I'll leave that risk assessment up to you. Moving on, just a couple of things about the battery. There's a milliamp hour rating. Besides the cells, there's milliamp hours. This is 1300, 1300. See, there's just one extra cell here. 1800, 2200. All of these are pretty much overkill for the drill. For example, this guy's used for flying jets, and this guy's used for flying helicopters, and this guy's used for flying quads, and all of those things require way more power than running a drill. So you're not going to have any problem with power. The way batteries work, the batteries don't push the power to the drill, they just provide the voltage. The drill pulls the power from the battery, and the battery will just keep its voltage stiff, allowing the drill to do all that it can. But for example, if you put this guy on instead of that guy, it's not going to run the drill any differently, because they'll both be able to provide a stiff voltage to the drill. The main difference is you'll get longer lasting, you'll get more life between charges with this guy. Okay, so I thought I'd talk a little bit about my design approach to this whole thing. So to start off, I modeled the pieces that I am going to keep from the original drill. So I started with this cover top, and I did this by scanning the bottom as I showed in another clip, and then lining up the holes, and then I used a micrometer to measure all the other pieces. So that looks like this. And once I had that in place, I modeled and kind of placed a battery just to get an idea of where I wanted it. So originally I had the battery a little bit closer, but I decided that I needed, to plug in the battery. So I put a plug there. We're getting close now, and then there's clips on each side that I wanted to have. So I added each of those clips here and here. And those are, again, from the original. And then I modeled the screws mostly because it's very fast to do, and that way I can make sure that the screws don't punch through. I don't make this part too short. So I'm doing all this in a program called Fusion 360, if you haven't heard of it. And this is professional software made by Autodesk, but if you use it personal, non-commercial use, you can use it for free, and they'll give you year-long licenses. So the next thing I made was the base. So that's the base there. And I'll remove some of these other pieces here. So here you can see where the screws go in. I'll remove the screws, the battery of course, and the plug. And there's a little cradle for the plug, and then a hole there because I was hoping that I would be zip tying the plug. And then for these little retainers, I have little holes to hold the metal part, which I just modeled off the original. These two guys here are for a support piece, because the original battery pack had batteries here and one other battery in the middle, and that battery holds this piece up, because this isn't actually glued in, it's just pressure fit. So what I need is some sort of thing to hold that up. So that's what I made for that. So I purposely tried to make this part a little bit springy, because too much pressure could break plastic pieces in here, but not enough pressure and this thing will just fall in. So this was my first attempt at striking that balance. So this just fits in there, holds that up. If for some reason it's too weak or too strong, you can design a different one and use these same holes here. And then the only other thing was the top here has a little hole there that I don't really have any purpose for, so I just made a little plug to keep stuff from falling in there. Alright, I started the printing process for the main base. The two other parts, namely the support and the little plug thing, I'll print as a separate step. Alright, we're about 3 hours into the print process, and it looks like things are coming along pretty nicely. A couple notes on the print. I'm using a 0.15 millimeter layer height. I could have almost certainly gotten away with using a 0.2, and that would have cut the print time down from about 9 hours to probably 7-ish. But I'm not really in any kind of a hurry, so just go for the slight bump in quality. The other one is the Prusa software has the ability to bridge these gaps here. So you can see there's filler support material being printed. By default, it would actually omit the support material in the middle there, and that would save on a small amount of filament and time in exchange for the print potentially failing. The reason I didn't opt for that is because the failure point, it would be, 5-6 hours into the print, and if something's going to fail, I want it to fail up front, not near the end. So as far as I can tell, we're through the part of the print that would normally cause problems, and the rest should be pretty smooth sailing. Okay, print's all done. I think it turned out really nice, except for there's a little hole there for the zip tie, which, because of the support setting I chose, it decided to fill that in with support as well. So that's going to be a little bit of a task to get that cleaned out. But outside of that, I think it looks good. I think this support stuff should come off pretty easily. So I'm going to start printing the other pieces and clean this up, and then I'll report back. Okay, we got 2 other pieces printed. This is the support that holds up basically this piece here into the unit, and then this piece here is just a little plug because there's a hole there that I don't actually have any purpose for, and I don't want things falling in there. Okay, I got it kind of put together. I got these clips in there, and they look pretty good. And for this guy, because I had to kind of dig out that little hole, I had to use a smaller zip tie than I wanted to. So I just used some hot glue to kind of fill in the gap. And then we have this, and the only thing left to do is screw the top on, so I'll just do that quick. Alright, it's all together now. I'm very happy with how it's screwed in and these clips. This part, I don't know if it's held in secure enough or flat enough. It only really has to engage once because I don't plan on plugging this and unplugging it a lot, but I may have to redesign that part if it doesn't work out. So to start, we'll put a battery in there. So I just got Velcro along the bottom here. So it just sticks in like that. And then, of course, if you wanted to put a voltage monitor there, you could, but I'm not going to bother. And then it just plugs in like that. Done. Okay, so now let's plug in the old battery, which is charged, but I charged it a few days ago, and these things are not great. So that's plugged in. Put it on the top speed. This is our power. No power at all, actually. It's already gone dead. Alright, well that's not very exciting. Alright, now we'll try the new one. This pack actually feels lighter. Slide that in. Plenty of power. Pretty awesome. That's all there is to it. And just to close, if you like this video, give her a thumbs up and consider subscribing. And I'll take that as a signal that I should make more of these videos and go more in depth. And if there's anything you think I can improve, please feel free to leave a comment. Thank you and have a good day.